Alright, sorry, I ran out of time finishing up 16 last time. It only lets me make 15-minute videos. So, anyway, finishing up this problem, let's find the probability that at most one household is tuned to Lindsay and Tobias. So, at most one is 0 or 1. Right? Those are the numbers that satisfy at most. Okay, you got to understand the difference between at least and at most, one or more, that kind of thing. You got to understand wording. So the things that satisfy at most 1 of these 20 households are just 0 and 1. Alright, so once again I can do a couple of different things. I can do the binomial. I can do the binomial PDF and just come up with the probability of 0, which is that, and then add to it the probability of 1, which is going through and doing the same thing but changing that 0 to a 1. I can do that. Alright, 0.024. Or the other ways that I could have done that same problem. Remember, if I do not put, excuse me, if I do not put numbers, that third number, it just gives me the straight up distribution. Now it's going to take it a while, and there's a lot of stuff in there. Right, a lot of numbers in there, but I only need the first two numbers. So even though there's a whole bunch of numbers in there, 0.00317, and then this one, so 0.00317 plus 0.02114, enter 0.0243, same thing. Okay, just add the first two. Alright, now, or I can remember that the CDF, this is what I want you to remember. If you just can remember, the CDF starts at 0 and adds until you tell it to stop. So we want it to add 0 and we want it to add 1 to that. So just tell it to stop at 1. And then there it is again, 0.0243. So if you get the hang of using the CDF versus the PDF, it'll pay off big time, right? Especially with these CDF problems. Alright, if at most one household is tuned in to Lindsay and Tobias, does it appear that the 25% share value is wrong? Absolutely. If only one household is, at most one household, 0 or 1, is watching that, then we are seeing something that would only occur around 2% of the time, assuming that 25% of TV households in America are actually watching that. So if this was true, if the 25% share actually is true, then what we just saw, that at most one household, there's only a 2% chance of that happening. So we're seeing something that's extremely rare, and definitely rare, less, compared to that 0.5%. So if at most one is watching that, does it appear that that's wrong? Yes. Why or why not? It's either going to be A or D. Yes, because 25% share rating, the probability that most one household is less than that. There's our answer. This one says the probability is greater than that. Obviously 0.024 is not greater than that. Alright, so part D again is just having you compare to that 0.05, that rare event rule that we've been talking about all semester. Alright, and then remember, 17 and 18, they're just telling you the shortcut formulas for standard deviation. So in this case, NPQ is your standard deviation formula. Take that square root. And then in 18, they want the mean. So the mean is just N times P. Alright, NPQ, if we look back at 16, which is a binomial, the standard deviation there would be the square root of 20. P is 0.25. Q is 0.75. So that's what we mean by using that formula. Now it doesn't ask for that in that problem, but that's the standard deviation from problem number 20. And then N times P, 20 times 0.25. Oops, don't need the parentheses. Alright, that's 5. So that, remember what this means is in this problem we should expect that if 20 households are in our sample, if this is true, we should expect 5 of them are watching TV. Or sorry, watching this show, if that 25% thing were true. So that's what the N times P, that's what the expected value of a variable represents. So we expect 5 of these 20 in our sample should be watching this. Alright, the standard deviation of 1.93, that kind of goes like with what we did before with the empirical rule in Chebyshev's. If I subtract 1.9365 from 5 and I add the standard deviation, alright, if we take just a bunch of different samples of size 20, we expect that 68% of those samples would have between 3 and close to 7 households watching that show if we did several different random samples of 20. You gotta remember 68%, that's if this is bell shaped. Alright, and then go back and do this times 2. And change that to a plus. And now we're 2 standard deviations. So we're roughly 95% of the time we expect, if this is true again, the 25%, if we just take a bunch of different random samples of size 20, we should expect that somewhere between 1.1 or 1 and 9 now, roughly 95% of those random samples of size 20 will have somewhere between 1 and 9 people watching that show. Right, remember, all that stuff that we did before is going to come back, and it's going to be true again once we get this test 3 material out of the way.